Thank you very much. Um, I was asked to have some welcome words for you, and I'm pleased to be able to do that as a former president of this institute and also coordinator of our Center of Applied Ecology. I had three words. And the fourth one is sorry for the delay, but things are going to start anyway. The three words that I wanted to share with you is one is for pleasure, the pleasure to be in the process with so many friends and colleagues from some that I know for many years, like Margarita, special thank you, and Eduardo and Marta and so many others, and our colleagues, Conceição, Irina, Catarina, Leonia, that are now going to host this meeting. The second word is memory. Of course, I think it's very important for all of us that are working with different hazards that memory is a very important factor. We know that all events, catastrophic events, they seem to come as surprises, but in fact they are not. If we enlarge the spatial scale or the temporal scale, we know that those events happen, they will happen in the future. They have a special time scale and a spatial scale, and therefore it's important for us to consider and to have our memory well present to be preparing in the future. The third word is about energy. I think energy is extremely important, and it's basically what puts together all the hazards. Basically, all hazards are sudden events of energy release. Could be from wildfires, could be from earthquakes, from heavy storms, heat waves. They are all forms of uncontrolled energy release. And that's why they have a certain unity and they can be worked together. But of course, we can learn with the different hazards. I think it's very important that these projects at European scale are taking place, because they allow us to share experience, knowledge from the various parts of Europe, share our knowledge, mutual knowledge, and basically understand that hazards are very, very much alike. They are all these sudden energy releases, and they have to be dealt as such. And actually, many of these hazards are also associated with global climate change, and climate change is also driven by heat and energy in the atmosphere that again is another another problem with energy. So I think it's very important for us to consider energy as the unit and the metrics that we can use for our work. And energy is also what is in the base of our relationships, the human relationships, and as atoms, they are put together by energy, energy that links us, and this good energy is the one that is on the basis of successful projects as this one. And we hope that this recipe will also provide recipes for politicians to tackle these hazards in a better way at the European scale. Well, thank you very much. It's a pleasure to be with you. It's better without echoes than with echoes, but it's better to be late than not being present at all. So I wish you a very successful meeting. I will be around also during the day. And thank you very much. And Conceição, the floor is yours. Thank you.
Okay, thank you, Francisco. It's always a pleasure to see you, even if it is on the screen. But that's life. New technologies are really nice. So now we will start with our presentations and also with the objectives of this workshop. So when we decided to prepare this final workshop, we had the main objective to share the main findings of the project regarding the challenges of the civil protection in order to face the increasing and the more complex risks context due to climate changes. So to reach this objective, we will present different tools that we have created during this project, and also we will have several discussions between external EU experts and also with many managers of other EU multi-risks projects. Since we are a little bit late and there are some keynote speakers that will have some commitments, we will change a little bit the program. So we will start with our invited guests. So we will start with Wildfires in Greece from Professor Margarita Arianatsu from the University of Athens. Then we will follow to Germany. So first we'll have wildfires, then we will follow to Germany for floods. So for the Federal Agency for Technical Relief, Mr. Hagen Wolfkrath. Well, the names are not easy. And then also we will go to Juan Terades from the project Monclima. After that, I will return here and present our project, our colleagues that will present the main project findings about the impacts of climate change in natural risk, civil protection, and emergency management. So Margarita, I think you are there.
I am here, yes.
Welcome. And so the floor is yours.
Thank you
Please.
very much, Conceição. Thank you very much, Francisco, for inviting me to this interesting workshop. And I apologize because I have to leave the meeting earlier because I have a class right after that. So I share my screen. Okay. So my talk will be a tour to the very many many wildfires we had in Greece, and that happened during this summer. We all know that fires are driven by several factors, some of which are acting at the local scale, some of which are acting at the regional scale, and some of which are acting at the global scale. At the local scale, it is mostly the factors are mostly related to land use, land cover issues, while at the regional scale are related to meteorological factors, and on the global scale to other issues like the global change. We all know that the Euro-Mediterranean region is a hotspot of fires, and there are several statistics pointing at this issue. And we all know that the land use changes that have occurred in the Mediterranean region during the last decades are very critical because they have unified the landscape, and they have resulted in the concentration of more fuel load and more flammable conditions. At the global scale, we have the predictions from IPCC that they say that we will have an increase in temperature, decrease in precipitation, and change in the regime of the precipitation, and more extreme fire events, most of which are related to more frequent and longer periods of drought and heat waves. And this global change is expected to modify the fire regime and the fire events in many regions of the world. Regarding Greece, some statistics say that we have, during the last decade, we had several fire events, some of which were very large, like those in 2007, and some of which were small. But what happened this last year? I'm going to show you after 2 slides. The predictions we have for the climate in Greece come from several studies, one of which is those that had been produced by the Bank of Greece from a committee consisted of by Bank of Greece. And in this picture, we see the change in expected mean air temperature between the periods 2021 and 2050 as compared to 1961 to 90. And in the right part, the relevant picture for the period between 2071 to 2100. It is obvious that the temperature is expected to increase by 1.5 degrees in the eastern part of the country for the first period, and all over the country for the second period. The same information comes for the rainfall regime also, which is decreasing. It is expected to decrease by 5%, and the highest decrease is expected in Crete, this island, and in Peloponnese. Regarding the number of the days with increased fire risk, they are also, for the same periods, they are also expected to increase, especially in the eastern part of the country for the first period and all over the country for the second period. Now, what happened last year? I will show you some of the many fire cases we had. One from Ebia, here this island, one from Attica, and one from Peloponnese. In a period of 20 days, we had more than 910,000 acres burned. Here is a picture from the northern Evia, the island I saw you from my country, and you see here the fire danger in this area, which is classified as extreme or very extreme, just for one day. But the same condition was also occurring for most of the days of last August. The same holds also for Attica, where Athens is located. Here is Athens. Here's Mountain Pyrnitha, which was burned in 2007. Francisco has visited the area. So during this very bad period of August in Greece, we had been supported by very many European countries in our effort to combat the fires. You see here some pictures. And the effort of these colleagues, of these co-Europeans, was really very high, and their contribution was very important. We had even support by Russia, from which we borrowed, we rented 2 very big planes to extinguish fires. Okay, let's go to Attica. Attica is here, Athens is here. So this is an area which was burned in 9th of August, and it is very peculiar because it is a typical case of WUI, of wildland urban interface, because in many parts of this periphery of fire, there are many houses. Like the ones you see here. So this is part of the area which was burned. You see here the results, and the houses burned completely to the ground. Another image of the same area. You see here an homogeneous pine forest, which was not treated before for any preventive measures. Here was before fire, and here is after fire, and houses built in the forest and then burned to the ground. And these houses were not just small houses, but very big villas. Now moving to Evia. This fire was really a disaster because it started from here. It crossed the island from south to east, and then it returned back to south, having burned all this area with a very high severity, and having caused severe damages in houses like the ones you see here, in infrastructure, in cars, and in the natural environment, and in cultivations. Here you see, if I don't know if you can read what is in the legend here, but there were many cultivations burned, and much of the vegetation, of the natural vegetation burned, from which the majority was Pinus halepensis mature forest and many olive groves. This was really a disaster. The pictures are like this. Some patches of plantations have remained intact, but the general aspect is like the one you see here. The fire has reached the beaches. You see here the olive groves, which were practically consumed. And a part of these damages, the prediction of potential soil erosion was really very bad, because most of the area is having steep slopes and unstable soil. So the risk of erosion was classified as very high in most of the area burned. This was a prediction. And also the landslide susceptibility of this area was also predicted very high. And the flood risks were predicted to be high in these areas that was burned. And unfortunately, these predictions were correct, because last week we had another extreme event. We had the Balos Storm. Balos is a a kind of a dance danced in the islands. So this dance of the rain was really very heavy and in many regions of Greece. And this is a picture from Evia. We had also very big fires in Peloponnese, which reached the beach, and had also the similar results, catastrophic results. And I select to show you this picture from Peloponnese. Yes, I'm almost finishing from Peloponnese, because here is Archea Olympia. Olympia is the area where the Olympic Games were happening, and this was also burnt in 2007 again. And again, the severity of the burn severity of this region. Now moving to some last places in Athens, in Attica. This is a large fire which took place in this area, which is near the Cape Sunion National Park, which also was burned in a severe way. And the last example I want to show you is from Attica again, from an area which was repeatedly burned this August. It started, as you see here, in 17, then it moved to the 18th of August, till to the 21st of August, where they managed to extinguish the fire. But then again, we had another fire in the 26th, which came back and burnt additionally the area. And in Attica, this is the areas which were predicted to have the most high risk of having flood risks. And actually it happened again, unfortunately, because this is the Kifissos River, which crosses Athens from the foothills of Mountain Parnitha to the Saronikos Gulf. And this is the river, and this is a bus from where the citizens were obliged, they were forced to get out and walk through the river to save their lives. So it is obvious that it is need for integrated forest fire management with greater emphasis on fire prevention, because usually we run after the fire to extinguish the fire, but the results are usually catastrophic and not manageable. Thank you very much for your attention and for inviting me to this very interesting workshop. Thank you.
Thank you, Margarita. Very impressive, the pictures and all the impacts after the wildfires. It was really impressive. So now we follow to the floods in Central Europe. So the floor it will be given to Hagen Volrath from the Federal Agency for Technical Relief, and please 15 minutes maximum. I don't know if the colleague is there. Mr. Hagen Volrath.
Hello?
Hello. It seems that we are with the ghosts in here. Okay, I think that.
Can you hear me?
Very low. Can you put your sound a little bit higher?
My sound's on maximum. It's better now? Hello?
Yes, for us in the room, yes. I don't know if all the participants. Is that okay, the sound? Perfectly, perfect. So, Mr. Hagen, the floor is yours. 15 minutes, please.
Okay, should be better now.
Yes, it is. You can start whenever you feel like it.
Can you see the presentation?
Yes. Not now, wait. Yes? Okay, the presentation is okay. You can start.
Okay, thank you very much. So thank you very much for inviting me to the conference. I'm giving a short overview about the floodings in Germany in July this year. As you can see, we had the event on 14th and 15th of July. It was a depression called Bernd, and we had a regionally heavy rainfall from more than 150 liters per square meter rain in about 24 hours. The maximum was at 240 liters per square meter. All this happened over narrow valleys with a saturated soil. This caused an accumulation of water in small river basins, flash floods, and following severe floodings in the area. We had about 100,000 affected persons, 823 were injured, 182 dead persons, and we have still missing 3 persons. Last week, 1 person was found at Rotterdam, where the flooding pushed the person through the rivers. We have about 3,000 damaged buildings, and we have about 500 totally destroyed buildings. And at the moment, we have about 1,200 emergency forces workers in the area. In Germany, we have a separated system. We have the federal government, which is dealing with civil defense agencies, and we have the federal states with civil protection agencies. But the federal government supports the federal states on request. In the federal area, it's the federal police, and that's the Technical Emergency Service or Federal Agency for Technical Relief, and the armed forces. And on the states level, it's the fire brigades and some other rescue organizations, for example, the Red Cross. With some short overviews over the situation in the field. This is during the flooding.
Können wir eh nichts machen. Nee, aber du musst ja die Polizei trotzdem bestimmen. Ja. Wenn einer drin ist, der ist das offen. Wer was nicht ist, von wer was ist, 21 machen.
So this is the river A, and normally it's about 5 to 8 meters wide and about 20 to 30 centimeters in depth. What followed the flood were extremely destroyed public infrastructure, power supply, water, gas, sewage, telecommunication, including mobile network and radio, and also including all the communication facilities for the emergency services. We had destroyed traffic routes, and in the area of the A, we had 62 bridges destroyed and 13 bridges partly destroyed. So it was not very easy to get to the infected or influenced people. This is an aerial picture of the Ahrtal of a small village called Brück. On the left side, you can see the area before the event, and on the right side, you can see the area after the flooding. And you can see that many parts of the infrastructure are totally destroyed. We are now facing the challenges of these events, so we are still in the lessons learned phase. But we figured out that we have a lot of things we have to keep in mind for being prepared for the next floodings. That's not only the land management, but also the technical equipment to deal with such events. At the moment, we are still in responding the followings of the flooding. Rescue and evacuation is finished. Assessment of buildings and infrastructure is still going on. We had to set up a base of operations for about 5,000 emergency workers. The rubble clear up is still going on. In this week, we are building 3 bridges in the R Valley. We support local companies and local water companies by providing drinking water and take care of the sewage. And we are doing everything possible to get the power supply running again, because as you all know, it's getting winter and many houses don't have a heating system yet. We have to ensure a warning system if there will be a second flood. So we use mobile water level measurements along 2 rivers. Here you can see where they are located. But the number of our members on scene is now going back. So in the maximum we had about 2,500 on scene, and now it's about 300. And totally we had about 15,000 THW members in the field. We are now at 2,250,000 hours of operation, and we don't know when the operation will end. So if you have any questions, feel free to ask, and thank you very much.
Presentation, also very impressive. Now it's on, I think. So we will pass to the next speaker, that it's Mr. Juan Terades from Montclima. So you can put all the questions in the chat. And after the presentation of Mr. Juan, we will ask the first questions to Margarita, because she has to leave at 10:30 Portuguese time. So let's see if we manage to have some replies from Margarita. But now we follow to Mr. Juan Terades from Montclima project.
Hi, can you hear me?
Yes, we can.
Okay, so hello everyone, good morning, and thank you very much for inviting us and inviting to present this Montclima Sudoe Montclima project. So now I have to share my screen, right? Okay. So let me know, please, if you can see my screen. No.
No.
I don't know why it's not working. Let me try again. Sorry about that. Okay, come on, not now, please. Okay, that's it.
Yeah.
Can you see my presentation? Hello?
Yes, yes.
Okay, so yeah, my name is Juan, and yeah, I'm going to present a little bit this Monclima project. That is an Interreg project born of the conviction that mountain areas are among the territories most affected by natural hazards, and also that risks are expected to increase due to the effects of climate change. So more severe droughts, higher average temperatures, and changing rainfall pattern, as we already saw this morning. And in addition, these risks do not respect administrative limits and need transnational cooperation to enhance disaster risk reduction, let's say. So with Monclima, what we want is to strengthen a risk-based approach to climate change at cross-border level in Spain, France, Andorra, and Portugal, in line, of course, with the United Nations, with the Sendai framework and the Paris Agreement too. And yeah, our main objectives are to improve the knowledge on the management of natural climate risks in these mountain areas, to implement different pilot cases to improve the knowledge on natural risk prevention and management through specific risk prevention and management strategies. And then to define also, with all this experience and findings, to define a transnational strategic framework with recommendations and good practice focus on mountain areas at cross-border level. And then, yeah, to transfer all these risk prevention findings and recommendations to mountain managers, let's say, to the priority stakeholders that are involved in the disaster risk reduction and climate change adaptation. So the working group 1 is based on the capitalization of all the existing good practice and the instruments of management and prevention of natural risks through 3 specific actions, let's say. The first one is to consist in generating a database on and subsequent analysis, of course, all about of the risk management and prevention good practice nowadays in mountain areas in the Sudoe region, and with specific criteria, no? Selecting only the good practice in disaster risk reduction and climate change adaptation in specific mountain areas, in synergy with climate change adaptation, of course, and taking of course climate change into account. So, and integrating also the multi-risk vision that is really important for us, and of course the transnational spatial scales, because natural risk doesn't know about administrative frontiers, boundaries. So yeah, that's a little bit the results. I mean, the project is still ongoing since it will be finished next year in December. So we don't have really final findings or results, but here you can see a little bit what is the first action of this working group 1, that is an exhaustive research of good practices and of this of 4 specific natural risk. And the main product is of this action is the analysis of this 70 good practice that we identify as very interesting. Putting special emphasis in these 4 criteria that I mentioned before, and then we select 7 good practices in order to organize this, what we call the missions, something like a capitalization mission that consists in visiting these special or particularly interesting good practices in order to have and achieve more information about that, and then to capitalize this in a map viewer and that I will show you later. So that's the first step of the capitalization working group. Then that's the result we expect, this on-site visits of the capitalization visits, and with these interviews, and then we will integrate this all this analyzed in a report, and all this let's say, practical information and also cartographic information in a map viewer. So then, yeah, that's a little bit the other action of this capitalization working group, that is to analyze, or we analyze more than 300 data set at the European level, but also at local level in the 4 different countries that are involved in this project, and relating to the main information of interest of risk of floods, of fires, droughts, and erosion, that are the 4 natural risks that we focus on in this project. So this map viewer aims to bring together in just one place all the available information on vulnerability, historical data, future projections for these 4 risks, as well as also detailed information about the different pilot cases that we are also implementing, 5, and of the best good practices, let's say, in risk and hazard management that we identify in the action 1. There are here some examples of the different layers that make up this this map viewer. Each one is referenced with the organization that provides this data, and that's a little bit some of the information we include in this map viewer. So the last action of this capitalization working group is a technical and legal analysis of natural risk management of this study area. And for that, we include also an analysis of the different climate change strategies that are going on in these areas, in order to identify which of those strategies are including natural hazards in these strategies. And we are now implementing or redacting a report that includes also recommendation to improve this management and prevention of these 4 risks, also from a transnational perspective and a mountain viewpoint, let's say. So the working group 2, I mean, the objective of this working group is to jointly with all the partners, but also with main stakeholders, define a framework document to integrate, let's say, operational and strategic recommendation for each axis or each risk, based on the results of the capitalization working group, and also of the best practice and the findings of the implementation of the action plans that we are implementing in the 5 pilot case of the project. So yeah, and the idea is now we are like working in the draft, and this month is going to start the consultation process with the main stakeholders that are involved in the disaster risk reduction in the 4 countries. And so we are trying to define these strategic recommendations that will be then let's say subdivided in operational recommendation. And these operational recommendations we focus on a promotion, a little bit the use of innovative methodologies, an active to promote also an active management of the territory, adapted forest management as a tool for enhancing the agro ecosystem and their resilience, to maintain traditional agriculture, extensive breeding, etc., the conciliation and compensation and evaluation formulas for the rural population, and also the cross-border dimension, no? Taking also into account this cross-border dimension. So yeah, regarding the working group 3, that are the design and the implementation of joint action plans for this to get more knowledge about and to test different strategies for prevention and management of natural risk. So yeah, the aim is of these 5 pilot tests is testing different prevention and management strategies for these 4 natural hazards. Some of them are more focused on combating a particular risk, an individual risk, and as is the case, for example, of the pilot case of agricultural management of vineyards to reduce erosion. And in other case, the pilot experience deal with more than one risk at the same time, and others focus specifically on the preparation of multi-risks management plans, as the case of Pyrenees Atlantics in a valley of Valentine. So, first of all, the case of La Rioja, the pilot case of La Rioja Alavesa, consists of the implementation of these different vineyard management strategies, soil management strategies, in this area of high viticultural interest, most of which is vulnerable to water erosion because of the slopes. So specifically, trials have been carried out on different plots in the vineyard, through the application of 3 soil management strategies: the no tillage, the intermediate tillage, and then with vegetation covered. I mean, with vegetational cover, sorry. And then the first one, a conventional soil management, so without cover. So for the 3 soil management strategies, at the moment, measurements have been carried out to determine the degree of erosion, as well as the changes in the oenological properties of the grapes and the greater or lesser resilience of the different plots to pest. So yeah, we can conclude here. I have no time to get in deep of these results, and also because they are preliminary still. So, but we can conclude that the reduction of soil erosion is, in the case of conservative management, or with a spontaneous plant cover, is about 64% compared to conventional soil management. So for considering erosion, this mulching or natural cover works very well. So similar preliminary results were obtained for the other variables of the resilience and the plagues, but at the present there are not change in we have not finding concerning the enological characteristic of the grapes, depending on the different management options. So that's another one. That's the pilot case that we are implementing in northern Catalonia. So here we are applying 2 adaptive forest management strategies to test their effect on the resilience of mid-mountain forests to climate change. So this pilot action aims to demonstrate how adaptive forest management based on recuperation of mosaic landscape or mosaic landscape restoration can increase the resilience of this mid-mountain ecosystem to forest fire in a specific point that is called strategic management point, what we call that like that. Why? Because these points are strategic, as the adaptive forestry actions carried out at this point are very able to limit the further spread of a potential fire because of prevailing winds or the effect of local orography. And also, they are also a key access point for the better and risk-free, let's say, firefighting. It's okay? Okay. And yeah, during the trial, some previous results during the trial, different variables have been controlled, among which humidity, composition, and general health status of the treated plots. And in general terms, we began to observe that in the tested plots, the moisture content of both of the main species, Quercus and Erica vegetation, as well as the general health status, showed improvements after the application of these strategies. So I'm going faster. Then we got the 2 case study of Andorra. The first one is consists of enhancing the protective role of an area of mixed forest by applying adaptive management measures to limit potential forest fires, and at the same time providing, of course, greater vigor to the forest, health status to the forest, and so enhancing its defensive role against falling blocks, basically. The area is very close to an urban area of Andorra la Vella. So the second pilot case that we are implementing in Andorra is a pilot case consisting in applying natural-based solution or natural-based measures through a staggered succession of micro dikes of plant material, organic material. In this area, which is located within a natural park and has special regulation limitation concerning green intervention, there have already been several episodes of high erosion and mud flows after intense precipitation events that have affected the town and main water treatment plant, so affecting important human infrastructures. So interventions are complemented also by several campaigns of natural organic fertilization, and showing also native seeds through in order to try to help to fix the surface layer of the soil, let's say.
Can you conclude, please?
Yeah. So we have also implemented two study cases in France that are more related with this multi-risk point of view, integrating all the risk of the area at the same time, and of course working closely with the local local actors, with the local authorities, in order to apply a methodology for prioritizing action and optimize the resilience of this area. So yeah, the working group 4, that is the last one of the project, is based basically in the transferability seminars. We already did 3 of these transferability seminars, and we invite you to participate in the next one. It's coming soon, in the Andorra La Bella seminar that will be focused on flood risk and prevention in mountain area. And yeah, that's my last slide about what we are doing in the OPCC, the Pyrenees Climate Change Observatory. We are currently developing a trans-Pyrenean climate change adaptation strategy. So this strategy is a cross-border strategy based in cooperation, of course, and in the Pyrenees bioregion, and designed to support, let's say, the climate policies of the different territories involved. In these various participatory workshops that we implement for the preparation of this strategy, more than 300 people from all the territory and all actors were involved. And the strategy includes 5 very cross-cutting, let's say, system, and the issue of natural and climate risks on the population and infrastructure is being addressed in the population and territory system. So in this sense, the different priority actions are being defined, let's say, in this topic, partly thanks to the previous works and projects that we are implementing from the OPCC. So Fusicos is another project, MidMac, and also this Pseudo-Hemoclima. So it's a very example of capitalization of all this information and how all this is helping to prepare the ground for this adaptation strategy. So thank you very much. And any question, please?
Okay, thank you so much. So since there are several questions in the chat, in this Zoom, but because also this this workshop is presented on YouTube, that they don't have the opportunity to see the answers that are on the chat, I would ask to Margarita if she can do like a summary of the questions that I've seen, that there are several questions for you. So if you can just do in a small summary what they have asked and what are your answers, since there are some people that cannot see it. Margarita,
okay, thank you, Conceição. Yes, most of the questions were related to whether there are already some preventive measures in Greece for coping with fire, and also what is my opinion or people's opinion regarding spending more money for firefighting or for prevention. I tried to stress at the end of my presentation, I know that it was short, but I tried to do that, that we need more preventive measures and more effective measures, and these measures need to incorporate also the people in their planning. For example, I would say that people should not be allowed to build their houses in the forest, in a flammable forest, but if they decide to do so, then they should undertake the cost of protecting their houses with several measures that can be taken in advance, and not asking the fire brigade, okay, come here to extinguish the fire which is approaching my house, because the fire brigade cannot I mean, be like an octopus everywhere. Also, the cost would be less if the emphasis would have been placed in prevention instead of firefighting, and prevention can take many perspectives. People should be involved. Fire breaks should be constructed before the fire, because right now they were trying to open fire breaks now. I mean, during the fire, which was crazy. On the other side, two of the areas were very near to very important places like ancient Olympia or Cape Sunion National Park. In these areas, they should have been taken very important, very critical preventive measures to avoid these damages after fire. So this is the main topic of the questions I received. Thank you.
Thank you so much.
Thank you very much too.
And thank you for having the time to be with us now. I know that you need to go to give classes, so thank you so much for coming.
I apologize for that. And thank you again for inviting me to be part of this important.
Okay, thank you. Bye. It was a pleasure to see you. Bye. So, and we continue with some questions. There were some questions for Mr. Egan Volrath concerning floods. So if you can also do a summary like Margarita did, it would be nice, because I've seen that you have done also some replies.
Thank you very much for the questions. It's very similar, fighting fires or fighting floods. You have to do prevention, and you have to have the equipment for fighting those things. So there were questions about the precipitation. It was about, I think, 150 to 260 liters per square meter within 24 hours. We had questions about the last floodings in the Ahr Valley. The last similar one was about 80 years ago, and minor floodings occurred in 2016. And then there was a question about the social effects, which are very severe, because you have about or you have several thousand affected persons, and most of them still don't know how they can get through the winter, or if it's possible to build their homes again, if they can live in their homes again. So it's a quite strange situation in the middle of Europe. I think most of us wouldn't know what to do in such severe situations. And if I've seen it correct, that's all of the questions.
Okay, thank you. I don't know if there are some more questions in the chat, because I cannot see it. Irina, we don't have more questions to Montclima? No, it doesn't seem that we have. So thank you so much.
Thank you very much.
And very interesting presentation. These topics are always very very impressive. So now we will continue with our program. So now we will have, well, the first main project findings. So, and it will be with David Pages from the General Directorate of Civil Protection from the Government of Catalonia, and also with Barta Giambelli from Cima Foundation and Guilherme from Pau Costa Foundation. But we will start with David Pages. David, the floor is yours.
Can you hear me?
Yes.
Yes, okay, I'm gonna show the presentation. I think I'm already sharing. Okay, I think you can see me the presentation. So good morning to everybody. Thank you for attending this presentation and this workshop. My name is David Pages and David Pages, and I'm currently working for the Directorate of Civil Protection in Catalonia. And first of all, I would like to acknowledge Nuria Gasulla, who is contributing also to this project and to this presentation. And the presentation tries to summarize part of the results we have found during the first part of the project. So let's move on to the first slide. The objective of this part of the project was to identify gaps and operational data requirements to be considered during risk assessment and planning process, and also identify these gaps and these needs to enhance the civil protection capabilities, taking into account an integrated prevention preparedness response. So and the methodology was based on interviews conducted to civil protection operators and emergency management experts conducted by each partner. So each partner in each country conducted this series of interviews. All the interviews are homogeneous, are the same for everybody. Then we summarized and sorted by cross-sectoral components of risk management and by risk also. And we tried to match each need with the driver factors that we already found in the previous step. So we have a totally of 49 interviews all over these countries, all over the hazards, storms, landslides, and rockfalls, floods, avalanches, and forest fires, as you can see. And it have a wide vision, integrating from national experts to local, going through regional also experts. It includes many institutions, civil protection, risk assessment, prevention agencies, firefighters, and decision makers also. So let's go to the main findings of these interviews after sorting all this information and gathering. So the first needs that we identified was that we have to enhance the civil protection view in urban planning to avoid new vulnerable elements in hazard zones, but also to consider visitor and tourist in the planning, because they have different needs and language and different culture maybe, or different knowledge about the country. But also to do all these improvements, we need political and financial and long-term support, and also to promote an integrated view of all the risk management. Moreover, in the risk assessment, mapping and planning tools aspect, we identified that we need to consider climate change in the civil protection and urban planning at all the levels, national, regional, and local. Also, here we can see improve early warning systems to advise in advance, and also support local scale with more tools and with more resolution, like risk maps. We need more resolution to the risk maps. In the next category, we identified also that we need more practical trainings and drills, because we need to shorten the response time. But we need also data exchange between institutions, more coordination and cooperation. It is essential because when the event is coming, we need that everything goes very efficient. We identified also that we need cost efficiency criteria. And what else? Going to technical measures, we identified also that we need integrated platforms. It is an important point. It is a very technological need. It needs more monitoring tools also to feed these platforms, more data management and visualization tools also in these platforms, and also decision support systems, as we will explain later. And also an important final point is reliability of communication and power supplies, because without these communication systems, we cannot use these tools. In the risk culture and communication, there is a lot to do. Enhance the participation of population in planning, to support this planning and to assure the engagement of the population. Also, good communication with this population. They need to know the exposition and self-protection that they need. Also, communication tools with the population during the emergency, and self-responsibility and resilience. And finally, in the recovery stage, we need to apply lessons learned protocols during the after event stage. We need written protocols to be applied and to learn how to improve. So this is the end of the presentation. Thank you very much for your attention. And now the floor is for Marta.
Thanks, David, and good morning, everyone. I hope you can hear me well. So after having deepened all the needs of civil protection in the current state, in a few minutes, I would like to present you some insights from the RECIP project regarding climate change impacts on hazards and risk management, collected from a documentary review, and also from interviews conducted by the consortium to civil protection risk managers stakeholders. And finally, I would just fly over a few insights related to potential multi-risk situations in a climate change context. So the RECIP project carried out a documentary review on climate change impacts on each of the hazards encompassed by the project, so wildfires, landslides, rockfalls, floods, avalanches, and storms. And some general trends have been identified, such the one depicted in this slide and also presented by the previous speakers. So as we have seen, the climate change is affecting
because it's not seeing.
Sorry.
No, you don't know. You can see the screen.
Yeah, I can see it.
People online cannot see it.
Okay, here we are. Yes. Okay, perfect. So as I was mentioned, here we have reported some general trends of climate change impacts on the hazards considered in the project. And as also have been mentioned by the previous speakers, climate change is affecting natural hazards, and it is projected that there will be a change in the frequency and the intensity of events, and also a different regime of occurrence, and also potentially new areas at risk. And additionally, when we speak about climate change, it is worth reminding that climate change and its impacts on hazards and risk are affected by a high level of uncertainty. And moving to risk management in a climate change context, this is something that disaster risk management actions and policies should address, among others, by maintaining flexibility in the development and implementation of these measures, and developing improvements even in absence of climate change, or taking into account a certain range of climate impacts. So current risk management policies and practices have been challenged by these new risk scenarios and more complex risk scenarios related to climate change, but also related to all the development processes. And this claim for the need for a new approach able to address disaster risk management in a climate change context, starting with a greater collaboration between all the stakeholders involved in the disaster risk management, and a more deeper engagement of the different actors in disaster risk management and early warning system, also towards a more integrated and holistic approach of disaster risk management, supported by a better governance and also a clearer chain of responsibility and competencies. And of course, all this new approach should be supported by new tools for disaster risk assessment and planning. And the further remark is that disaster risk management needs also a bigger and consistent financial support to do so. So this, sorry, I should change there. Okay, perfect. So this documentary review has been also enriched within the RECIP project through a qualitative survey which involved civil protection stakeholders and risk managers, with the objective to understand better the main challenges and needs for facing climate change from their perspective, as they are also the end users and beneficiaries of the results of this project. And in particular, the consortium interviewed 54 civil protection operators and 27 risk managers from different administrative levels, so from the national to the local level, and coming from also different authorities and with different roles. And the needs emerged from these two groups of stakeholders, confirmed also what has been found by the review, and also what has been found in the previous survey presented by David before. And some common needs expressed by both the stakeholders group are in fact the need to reinforce and strengthen the collaboration and cooperation between institutions at different levels, but also within the same agency. And this is true not only during the emergency phase, but in all the phases of the risk management cycle. And risk managers added to the need to innovate the approach of risk management from the concept of protect all to a new paradigm that live with risk. And another common need is the need to better understand these new risk scenarios and to integrate climate change impact in risk analysis and mapping, but also to continue understanding and managing the actual risk, so the actual exposure and vulnerability existing in the territory. Moreover, both the groups claim for the need to raise risk awareness of the population, also by involving the community in the disaster risk management, development and implementation of measures, such as in the civil protection or emergency planning process, reinforcing also the risk communication and risk perception. And moreover, civil protection operators highlighted the need for an improvement in the early warning system, especially in the forecasting and monitoring measures, and also the need to have new real-time tools to manage an emergency and to support decisions, including monitoring tools. And finally, the risk managers added the need to integrate territorial urban planning, forest and agricultural policies in the disaster risk framework. All these needs has been translated by the consortium into measures that reduce risk in all its components and that are referred to all the phases of the risk management cycle. So we identified a diversified portfolio of approaches, but of course, as you can see, most of them are prevalent related to prevention and preparedness. So there is this emphasis on these two phases of the risk management cycle. And finally, with all this information and knowledge collected, the consortium tried to explore different potential multi-risk situations in a climate change context. And by multi-risk in these cases, we meant mainly cumulative effect over time. And the scenarios explored are reported here. So there are storms, wildfire and wildfire storms, wildfire floods, wildfire avalanches, wildfire landslides, and wildfire rockfalls. So just to try to sum up some insights, the risk, what we obtain is that the risk of wildfire has an effect and an influence on the other natural hazards, but also other risks can increase the risk of wildfire. And also, as presented by the speaker before, like in the case of Baby Island, the multi-risk situation imply a response to a previous emergency situation that had modified the risk in the territory. So it creates like a new scenario with a more unstable and hazardous terrain where the future risk, a new risk has increased. And moreover, of course, the territory affected by an extreme event should be reinforced and protected in order to minimize and reduce the risk of other possible natural hazards. And these reinforcements need to be implemented as quickly as possible through concrete measures that allow to organize the action, but also to coordinate all the involved stakeholders, such as, for example, through the development of protocols and measures. So with this, I concluded, so I just showed some of the general findings from this work package, but you can find all the detailed in the report, you can find in the webpage of the RECIP project. And so thanks for your attention, and also thanks to all the civil protection operators and risk managers that have been involved in the interviews. Thank you.
Thank you, Marta. So now it will be Guilherme that will be presenting. Change the slides here and just point there.
Thank you.
Wait, I need to make the slides first.
Okay. So thank you very much, Marta, David. It's great that I present after your presentations, because it's like my presentation is the next step of the project after the risk analysis and the impact of the climate change on the risk and risk management. And now a further step of the project has been the guidelines to incorporate projected climate change impacts into decision super systems and platforms. So we have seen the impacts of climate change into risk management. So this is the baseline of these guidelines. We know that we are in a changing climate and a changing landscape. So these dynamics from the climate and the landscape pose new challenges and new risk scenarios that we have to work on. So in that sense, one of the steps that we should and we can undertake to enhance the risk management is to enhance the decision super systems that we have. So in the framework of RECIP, a decision super system is any tool that can help risk managers to make better decisions, to reduce the uncertainty of their decisions. Okay, so we can understand a decision super system as any well, it can be computerized or human-based, dynamic or static, commercialized or specific for any organization. It can be local, regional, national, international, or even cross-border. And finally, it can include single hazards or multi-risk scenarios. But the main 5 pillars of decision super systems are the models, knowledge, documents, data, and communications. Okay. So the objective of the guidelines to incorporate climate change impact into decision super systems is to better understand the information and the data we need to address the scenarios posed by climate change and according to the experience of the civil protection. So how we can improve this decision super system according to the civil protection agencies need. Okay, so to develop the guidelines, what we have done mainly is a set of interviews to civil protection bodies across Europe and particularly to the countries of the RECIP partners. So this has been the main part and the basis of the document. Then we have to took advantage of the lessons learned during the development of the operational tools that we will see later, and the main findings regarding the previous studies, the climate change impacts on risk management. Then we did a total of we analyzed a total of 18 decision super systems across Europe, and for each DSS we gathered general description like the scope, the hazards that it can tackle, and so on. Current capabilities for current scenarios, current capabilities that are still helpful to address future scenarios, and capabilities that do not exist that will be helpful to address the future scenario under a climate change context. So I jump into the results. We organize them according to the 5 pillars of the decision super systems that I mentioned before. So according to the experts in regards to the data, they agreed that the organization of data according to the emergency phase in prevention, preparedness, response, and recovery, it's a key input for the decision super systems in order to have better organized data and to rapidly move across the decision super system and find the appropriate section to address the risk. The monitorization of exposed and vulnerable elements. Then updated data gathering. In this point, we have like 2 points of views. The first one is that once you put data into the decision super system, it's automatically out of date because we live in a changing world. It's true, but there is the other point of view that is also true, that there is some data that for its nature is always, or at least it's up to date during some years or even some decades, like the flood risk returning periods or urban areas, for example. Then another shared comment was to include economic and environmental expenses into platforms. Okay, we are used to see to count economic losses or environmental losses after the event, but it's important to include this information in the preparedness, prevention, and response phase. Why? to know, imagine that I'm managing an emergency. If I have the economic and environmental data, I will be able to decide where to put my efforts or not, according to these inputs from the beginning, not in the recovery. And another point was real-time positioning and health monitoring of first responders. Of course, this is something that exists. There are technology companies working on that, and it's only about integration of this information into the DSS. About models, 3 important points shared by the interviews. The first one is climate change projection. So understand temperature and rainfall anomalies, translate these anomalies into landscape projections, because landscape then will have an impact on the emergency management, and how these landscape changes have an impact on the disaster scenarios. Okay, this is something that should be included in the decision super systems. Then the spatial scale. In the end, about the spatial scale, the shared comment was that it's about reducing uncertainty. We know that high resolution is usually less trustable, but we need to understand how to play with this uncertainty and manage this uncertainty of a high resolution. And of course, find the appropriate spatial scale according to the risk that we are managing and the context. And finally, the scenario matching. This is very interesting. This is about having the chance to include data from a previous incident, wildfire 20 years ago, for example. And it would be great if we can include the data of that fire, weather, topography, operations, and so on, into this decision support system, so that now, when I'm managing a fire, I can see what happened 20 years ago and see in advance the impact of my decisions. About knowledge, 2 very important points arise. The first one is social engagement as a decision support mechanism. Okay, it's about including and engaging citizens in risk management. So exchange information with them and make a risk analysis and co-creation of solutions of the risk, particularly for people that is exposed to that risk. I will go deeply through that later in the next presentation later this morning. And another point is to include recovery into the decision support systems. We have seen that prevention, even preparedness, and particularly response are tackled in most of the decision support systems, but recovery is the forgotten one, let's say. Of course, we map the affected area after the event, but it's important also to quantify losses, assess the success of the preventive and response actions, and then to find synergies between recovery and adaptation. So recover the area, considering the future scenarios, and adapt to these future scenarios. About communications, 2 very basic things, let's say. The first one is early warning systems. Okay, we know that citizens are the first ones to arrive to the incident area. So we need to find a way to gather trustable information from citizens, and even to be able to receive alerts from them in a quick and trustable way. And the second point regarding communications was to better coordinate between cross-border scenarios, particularly with the civil protection bodies and fire services across borders. And with this slide, I finish my presentation about documents. The first point is the integration of risk analysis into land planning. We are very used to this is something that is done for flood risk. We do not build next to rivers anymore, I would say. But this is something that we do not do for other kind of hazards like forest fires, or now, for example, in La Palma with the volcano, we have seen that a lot of houses have been destroyed. And this is something that should be included into land planning. And finally, the integration of accepted procedures into the decision support system. So confinement, evacuation, alert systems, or recovery programs, to include them into the decision support system to find, to have a more rapid response during the emergency. Okay. So yeah, this is everything from my side. Thank you very much.
Thank you. So since we are a little bit late, what we will do is that we are going to stop for 10 minutes so that all the people can go to the toilet, have a coffee, have a drink of water, something like that. And in 10-15 minutes, we will return. And at the end of all the other presentations from the project, from the second part of this workshop, there will be a place for questions for everyone. So, because as you have seen, a lot of things of this presentation done by our colleagues from RECIP has a lot of interconnections to the rest of the presentation. So it will be better to gather all the questions at the end, we will answer to them. So 10 minutes break. So at 11:05 Portuguese time, we will return. Thank you. Okay. So, to see myself here. Mariana, posso ter aqui? Sim, é só. Yes. Okay. Thank you for waiting. Now we are more comfortable after this small break. So now we will have a section with several presentations. So we will start with Matthias Florer from the Austrian Research Center for Forest, Natural Hazards and Landscape. And then we will carry on with more 4 presentations. So please, if you have questions, just write them on the chat, on Zoom chat. And then at the end of all the presentations, we will discuss and present all the questions. So thank you. Matthias, it's yours.
Thank you, Conceição.
Just a little bit. No. No, yes. On the computer, yes. Not on the screen. Oh, okay. So you can start.
Okay. Can I skip it? Yeah. Okay, it's working. Thank you. Okay, welcome to my presentation representing the BFW from Austria. My topic now is impacts of climate change on landslide and rockfall risk management, decision support system prototype. So, what was our inducement for this topic? It skips around. So as all of you know, the multifactorial issue of natural hazard management becomes even more complex because of the climate change. And all of you also know that the combination of different natural hazards and or climate change impacts can significantly increase the hazard potential, of course. So in this context, decision-making and civil protection in the field of prevention are fraught with uncertainties. So the main question for us is how to handle maybe decision support systems and how can they reduce these uncertainties. So the overall or the overarching reset goal is how to develop recommendations, guidelines, or tools for as decision-making aids and supports for applied civil protection. Therefore, in the course of the project, we developed a prototype for decision-making in the context of rockfall and landslides risk management. We did some very important steps in advance. The first one is the identification of potential climate change impacts on risk management for rockfall and landslides. And the other important step was the analysis of existing decision-making basis for civil protection. So I just try to skip further. Does not work. Just a second, please. Okay. Yeah. First of all, we had to discuss which processes are we really focusing on, because the landscape of natural hazards is pretty big. On the one hand side, we focus on rockfall processes, and on the other hand side, we focus on landslides. Which rockfall we take into account? It is rockfalls up to 100 cubic meters, because that's kind of single block movement, and above 100 cubic meters, it's called rock avalanches. For landslides, we focus on hydrological driven, spontaneous and shallow landslides. So deep-seated, slowly moving, permanent landslides are not taken into account. What are the main impacts on these two processes? On the left side, you can see it's the permafrost degradation, especially in the alpine regions. And on the right side, you can see the deforestation, so the forest loss through bark beetle, forest fire, and windstorms and so on. What's the big difference regarding these two impacts? Permafrost degradation is affecting high alpine infrastructures like cable cars, restaurants, hiking and bike trails. So above about 2,200 meters of sea level. And the deforestation affects settlements below forest. So below protection forest site especially. Now I want to show you some pictures how we sketched the scenery interacting climate change impacts with these natural hazard processes and the different damage potentials. At the beginning, you can see the permafrost border about, sorry, it's skipping itself, on about a level of 2,200 meters now. That's the current permafrost borderline. And I'm sorry, it's skipping around pretty crazy. And you can see a current damage potential in settlement areas in alpine infrastructures, and of course we have got a current rockfall hazard potential already existing. Yeah, I don't know if does it work normally? Yeah. Okay, this should be the next slide. In the future, we have got, of course, increased damage potential in settlement areas, as well as in alpine infrastructures and in transportation infrastructures. In the next step, you can see a climate change permafrost degradation. So the ice in rock cracks is melting, slopes get unstable, and the future permafrost line is on about 3,000 meters, for example. So we also have got increased damage potential in infrastructures. And later on, in the next slide, you can see what happens if permafrost degradation is going on. We have got an increased frequency and magnitude of rockfall hazards, as well as landslides. So therefore, we also have an increased risk for alpine infrastructures, settlement areas, and transportation infrastructures. So what are the existing decision-making bases for civil protection? Especially in Austria, for example, the responsibilities are very fragmented and splitted up. In the risk management in the Austrian country, sorry, I got out of power now. Thank you. So in Austria, we can distinguish between local, regional, and national levels in terms of planning bases and responsibilities. And also in Austria, and maybe in a lot of other EU countries, municipalities and their bodies have a very central role. Thus, our DSS, our decision support system prototype is preliminary addressed to the municipalities. So existing planning bases, there are a lot, are often unknown or just applicable by experts. So in our country, there are no standardized procedures, the risk-based planning principles, but there are regional, for example, spatial mappings of hazard processes and the elements of damage potential. So very important now is that there is a big number of existing planning bases, which, however, do not take into account the climate change and its impacts. Now I will show you some examples of existing bases, which are partly area-wide, so for the whole state of Austria, or partly just regional available. Of course, maybe similar to your country, we have got event cadasters, we have got information maps on hazards, we have got danger zone plans, which more focus in Austria on avalanche and torrents and less to rockfall and landslides, which I am focusing on now. We've got geological maps, of course, soil maps and forest maps. We have got information on existing infrastructure and land use plans. And last but not least, a very important tool are the digital elevation models with its in-shade visualizations. So what are the current opportunities with the existing data? So the most of the data is freely downloadable. And we can make intersections of hazard information maps, for example, with existing infrastructures to identify potential danger hotspots. But at the time, spatial planning and hazard zone planning do not yet take into account the impacts of climate change and associated intensification of these natural hazards. So in Austria, now we have got kind of a static approach. But for modern risk management and civil protection, we have to consider climate change, and there is an urgent need of a dynamic approach. So we try to do new applications and especially combine methods. So based on direct consequences of the climate change, so temperature rise, we have to consider, implement, and apply rockfall and landslide relevant data. For example, very important, the Alpine Permafrost Index map, which is already existing, elaborated by the University of Zurich, and for example, maps of specific silvicultural informations. So now I just want to show you an illustrative example of what we did. We have got a set of existing data, like terrain model, a layer of infrastructure, and this Alpine Permafrost Index map. And we, of course, have a set of existing tools, like models and simulation software, which sometimes costs a fee or also is available for free online. This layer of infrastructure we overlaid with the layer of the Alpine Permafrost Index map. And a preliminary result is an intersection of existing infrastructure and the permafrost layer. And as you can see here, there is already a sketch of where the permafrost layer intersects with infrastructure like alpine infrastructures, lifts, and ski pistes on this visualization. So, okay, I try to carry on. So we identified rockfall release areas with and without permafrost degradation. So that means the blue rockfall release areas are below the actual or the current permafrost border, while the red rockfall release areas are potential release areas, including the permafrost degradation. Later on, we did rockfall simulations. On the left picture, you can see the pre-climate change rockfall scenery. So we just did simulations with rockfall release areas below the current permafrost line. And on the right visualization, you can see the rockfall scenery with implementation of climate change scenario because of melting of permafrost. So the message here is that rockfall propagation, of course, increases a lot, and many more infrastructure, in this case, especially high alpine infrastructure, is affected. I'm coming to the end now. How does a sketch of our decision support system prototype look like? We have got on the left side, we have got the pre-identified providers of existing tools, which I explained before. And they are also potential receivers of our new decision support system. In the center of the sketch, you can see the main responsibles and also potential receivers of new DSS, the municipalities, especially in Austria, and their official bodies like the mayors. On the upper right part, in this box, you can see the identified climate change induced changes of the environment, which I showed you, which I've shown you in form of permafrost and deforestation. And in the lower right box, you can see the application of the existing knowledge and the development of new tool combinations, like I showed you in the slides before. So the take-home message for us now is that in Austria, we have got a big set of many data, many information on where a rockfall could occur, where infrastructures are built, where danger zones are, and so on. But there's a big need of combination of all these informations and take into account everything which is available now, like, for example, this Alpine Permafrost Index map, which is information on underground ice, and official authorities and civil protection bodies not yet take into account in their hazard management. Thanks for your attention, and sorry for the technical problems at the beginning.
You can leave it there. So thank you for the presentation. Now, with no longer delays, we will follow to the presentation of Mr. Christoph Atterbrot and Caroline Meyer from the Forest Research Institute of Baden-Württemberg. These names, I'm so sorry. These names are amazing. So a participatory approach to develop a crisis management plan to manage winds through along roads. So I imagine that you are there. Christoph, are you there? Caroline? Sorry, Caroline, are you there? This almost seems Caroline?
Yes, can you hear me?
Oh, yes, perfect.
Perfect.
So
share
can
my
you,
screen.
yes, please. Thank you. You will have 15 minutes.
Thanks.
10, 15, please.
Just a sec.
Caroline, can you
Yes.
share the screen?
Oh, I'm having trouble. Trouble with the screen sharing. It won't let me do that.
Just a moment. Sorry, this switch on screens, the presential and the online, and well, it's a learning process.
Here we go. You should see my screen now.
Yes, we can see your screen in Zoom. But wait just a minute so that we can have also in the screen in the room. So it's already in the screen, Mariana. Sí. Sí, aquí. Okay, you can follow. Caroline, the floor is yours.
Thank you. So welcome from my side. I present here for the team from the Forest Research Institute in Baden-Württemberg, Germany. And my colleagues Yvonne Hengst-Erhardt and Christoph Hartebrot are in the room as well, in the virtual room. And I'm going to present an operational tool, participatory crisis management planning for wind throw along roads. And I'm going to start with a brief introduction to windstorm events. Storms can have severe ecologic, economic, and social consequences and threaten human lives and infrastructure. And they can evolve from a variety of meteorological conditions, but within RECEP, we focused on winter storm events. that tend to occur between October and March and typically have a vast geographic extent of about 1,000 kilometers. The risk of storm-related hazards is determined by natural conditions in any given forest site, including its topography, its soil structure, its usual degree of wind exposure, forest composition, and of course the characteristics of the meteorological event itself, including peak wind speeds and whether or not there was high levels of precipitation before. In combination with other weather phenomena, winter storms can lead to cascading effects or feedback effects. For example, a sudden temperature increase that comes along with an approaching storm front often leads to quick temperature rise and high levels of precipitation and snow melt, which ultimately can fill up creeks and streams that are blocked by downed wood. And that can have severe consequences locally and overwhelming situations for local emergency body staff. In the future, with climate change, the severity of storms is expected to increase, but there's also a number of indirect climate change related changes and effects on forests that also relate to storm impact. For example, we're expected that tree anchorage will change, the typical wind exposure will change, and the overall wind resistance of forests because of a change in forest composition, species composition. And finally, there's strong evidence for disturbance interaction, especially, for example, hotter and drier summer months and storms lead to interactions because, for example, a dry and hot summer reduces the forest's resilience toward pest or fire and insect outbreaks, which ultimately increases wind disturbance susceptibility, and the same thing the other way around. Even a smaller scale storm event increases susceptibility to, for example, insect populations, and then ultimately can also threaten forest areas that were initially not even touched by a storm. So what we focused on within RECIPE was how individuals working in civil protection and forest management can prepare and manage for winter storm events. And the operational tool I'm going to outline here illustrates a way for individuals and organizations to develop a crisis management plan for winter storm events in a participatory manner. But that procedure I'm going to present can also be applied to different disturbance scenarios, fire or other scenarios. And my presentation is based on a participatory process that we conducted in a forest district in Baden-Württemberg, so one of the states of Baden-Württemberg, Germany, in the southwestern corner. And the forest district of Oberkirch is located at the edge of the Black Forest and is crisscrossed by a number of high traffic roads that are of importance to the entire region. With climate change, this region is expected to experience higher intensity storms in the future, and hence the need to prepare for such events. So the process outlined is a way to structure collaboration through participatory development of communication pathways and information exchange. And what we did is we followed a 7-step process, and you don't have to, we're not going to go into detail of every step. Basically, we started by defining the plan's objective. What is the crisis management plan supposed to do? And it's important to outline exactly what you want to do and what problems you cannot solve. Then you contact relevant actors, and we interviewed them individually, workshopped with them, and then drafted a crisis management plan and finalized it with feedback. But what I really want to talk about in more detail is what's really at the heart of this process, apart from the individual steps, and that's what we call a process map. And you see here a more or less empty template for a process map. And it's a way of visualizing our thinking about crisis management and a way of visualizing connections across organizations. So let's start with the top line, the heading of the columns. You see the different phases of crisis management. You see prevention, preparation, intervention, and recovery phases. And for each of these phases, we distinguish activities that take place within the forest or alongside that road that goes through the forest, processes or activities that take place within the involved organizations. So in our case, primarily forest management agencies, civil protection bodies, fire departments. And then activities related to the environment, that refers to activities related to the general public, to media outlets or forest visitors, commuters on these roads that could be affected by storms. So when interviewing stakeholders and workshopping with all stakeholders involved, this process map serves to illustrate processes that require more than one organization to become active or engaged, or at least be informed about processes. It does not display all processes that are required for successful crisis management. And so because this process map merely visualizes sort of a summary of what should happen and what communication pathways are needed, each of the processes outlined here is accompanied by what we call a process brief. So it's a text document that shortly describes the process. It outlines who's in charge and in what form, so what each organization is expected to do. And then it also outlines which organizations or actors have to be informed or have to be participating in one form or another. And then lastly, it outlines what has to happen in order for this process to become real life and to become part of everyday activities and practices. So the process map we developed in our case study in Baden-Württemberg looks like this. And you don't have to understand or try to read every detail. It's more about the visual impression. You see, again, you will recognize it. The template I showed earlier with the phases of crisis management in the top headings and the columns and the different places that the activities take place. And so in our case study, what we found working with different stakeholders in a workshop is that they all agreed on a need to focus very much on prevention and preparation and improving communication and information exchange during these phases. So for example, they agreed to conduct road safety checks together between actors from forest management agencies and road maintenance agencies or road management agencies in order to have both the forest management and the road safety expertise together to make decisions about how to manage forests along a particular road. They also agreed to try to institutionalize a information exchange with contact information and geographic information about who's responsible for what part of the forest, which fire department is responsible for what part of that road and forest. So to sum up, this tool that I've presented here is well suited to visualize the interdependencies between organizations, the connections that need to be made and the networks that need to be built. And the process of workshopping with a diversity of stakeholders is an initial step toward building and strengthening these networks. And the process itself is probably just as important as that map it produced. But the real challenge is integrating these new networks and the information exchange into existing organizational structures. And that requires a priority to be put on prevention, preparation, and it also requires the necessary resources to be putting that priority on prevention and preparation. And with that, I thank you for your attention and look forward to your questions.
Okay, thank you so much for your presentation, and on time. You were the first one that had 10 minutes and followed the 10 minutes. So thank you so much. Well done. So please don't forget to send all the questions to the chat on the Zoom platform so that at the end of all the presentations, we can have a discussion with your questions and some others. So thank you, Caroline. So now we will pass to 3 researchers. No, first we will have Carlos Garcias, from the Institute of Cartography and Geology of Catalonia, and also Eduard Plana from the Forest Science and Technology Center of Catalonia. And they will present understanding avalanche synoptic patterns to prevent better risk scenarios in the Pyrenees and discussing novel wildfire avalanche multi-risk. So Carlos, are you there?
Hello, yes, I'm here.
Yes, you are there.
Can you hear me?
Can you share your screen so that we can start your presentation? And then Edward will come here and present the rest.
Can you see my picture? Okay.
Yes, yes,
okay.
you can follow.
Thank you very much. Okay, this presentation is divided in two parts. And of course, it deals with snow avalanches. I work in the Cartographic and Geological Institute as avalanche forecaster. And in the first part of this presentation, I will show you the tool that we have developed in the frame of this project to aid civil protection to manage snow avalanche emergencies. Currently, in high danger situations by avalanches, civil protection receives a regional warning describing the danger conditions. It means what can happen, where, and when. But this information is too much generalist. So how to improve this information? By means of the proposed tool, civil protection will receive a mid-term forecasting 24 hours, 48 hours in advance of critical situations. And that's the point, which are the most likely major avalanches prone to fall down for each region. This mid-term forecasting is based on the relationship between atmospheric situations and the observed major avalanches during the last 50 years. Major avalanches are those more than 1 kilometer long with capacity of destroying buildings and infrastructure. Analyzed atmosphere situations are 500 hectopascal geopotential topography because this level controls the weather on surface and defines the storm profile, precipitation, temperature, and wind. The parameters result in a specific avalanche problem. It means new snow, wind drift snow, persistent weak layers, wet snow, gliding snow. Of course, the short-term forecasting is finally based on the snowpack and instability conditions and analysis. So the aim of this tool is that civil protection gets ready for a likely emergency on avalanche in advance. The first step has been to date the major avalanches at daily scale for the last 50 years. Major episodes seem to increase in the last decade, but not the intensity, because if we look at the number of big avalanches by episode, they don't increase. The second step has been to classify all the major events of the database by the synoptic situation, taking a grid of the synoptic scale of northward of Europe. And by means of the principal component analysis, 9 patterns leading major avalanche have been identified, as you can see in this picture, from the most to the least frequent. There are advections, lows, and high pressure situations. Each pattern shows regional differences on major avalanche activity. For instance, as we can see in this picture, in the northwestern pattern or northwestern advection, the 50% of the activity is located in the northern region. In addition, avalanche activity is concentrated in specific aspects for each pattern. In this case, big avalanches have fallen down in southern slope majority. Another example in a southwestern pattern, activity is expected mainly in the western regions, and the avalanches are expected to fall on northern slopes. So it also lets civil protection to focus in a given region for a given pattern. From this classification, we can inform civil protection which are the most likely major avalanches to fall in a given region for a given day. This information is shown in a visualizer tool that in fact is our receipts result. The tool has two modules, module 1, that shows on a map the likely avalanches attending to the database, module 2 that shows possible avalanches. It means avalanche zones that have the same characteristics of aspect and altitude than the likely ones, but never observed so far. Coming to the module 1, there are 3 outputs: the likely avalanches, also avalanches of a small size but affecting infrastructures, and finally is also represented the maximum observed event for each avalanche corridor, but with independent of the atmospheric pattern. So this is an example of the visualizer tool in an iconic map at the moment. For a given day, classified in a given pattern, civil protection will see the location of the 3 outputs and the main characteristics of the likely avalanches, such as the potential damages. So it's the most important. And of course, civil protection can go in deep in the database to consult all the concerning information. So that's all from my side, and thanks for your attention.
Thank you. Now we will have Edward that will be presenting his part.
Good morning, everybody. So within this tool, we also try to include a reflection between the crosslinks among wildfires and avalanches.
Wait just a little bit.
Yeah, they're putting the screen.
You can breathe and relax and do some exercise.
Sure. And this is okay. Just some minutes. Some seconds.
Yeah, seconds, please.
Yes.
Not minutes, seconds.
With collaboration of course, from our side, CTFC, but of course with the Cartography Institute of Catalonia, also with Pau Costa Foundation, which help us to provide also the expertise in wildfires, and with, of course, the civil protection of Catalonia. We also had the collaboration of Chiara Sabella from the University of Bologna. And once the screen works, we can move to the presentation. Well, I take the opportunity of these seconds to also, as a coordinator of the project, to clarify that, as you see, we are doing a really big effort in summarizing all the results of the project, and all of them as was mentioned from some of us, are or will be available in the project website. And it is also inside the results of the project to edit a final book of guidelines, really addressed in a very practical way to end users, where also you will find on the final book of guidelines will have main project findings towards the end users. Okay, here we are. Nice. So I guess that we can move forward. Yes, okay. So as I said, we've started a discussion about what meets these two risks. Of course, it seems that fire and snow are an opposite elements of nature, but of course, fires are part of most of mountain areas. And it's interesting because it's just showing the both sides of fire. So fire as a tool, which is quite used in mountain areas for restoring pastures, even for well-open forests, clean vegetation, etc. But more and more, and science, and thanks to climate change, the hazard of these extreme or fast and intense fires are increasing in not only in Pyrenees, also in Alpine areas. And this means that these fires has the capacity to affect the canopy, which, and of course, if fires are affecting the canopy and killing the trees, we have a cascading effect, science will lose the forest protection function. So we focus the discussion in this operational tool. We were discussing about these fires, high intensity fires that suppose a problem. We are not including in the discussion the, let's say, fires that are helping mountain ecosystems, like low intensity fires that also have some benefits. So our discussion was based in 3 different exercises we did. On one hand, we carry out a tabletop exercise in collaboration with the Civil Protection in Catalonia, simulating a late summer large wildfire event, followed by an early fresh snow fall to all altitudes. This it's not really a rare. I mean, it's not happened already, but just trying to include climate change scenario is some feasible scenario that could happen. The other exercise we did is a discussion about the forest management prescriptions towards a common wildfire avalanche risk mitigation approach at forest stand level. And finally, we also are conducting a case study exercise assessing the potential wildfire avalanche risk situation in a valley in the Pyrenees. It is in the valley of Nuria. So the tabletop exercise basically just to send some important information here is that we really take advantage in this project of meeting different profiles of expertise, but not only in the sense of putting together the knowledge in avalanche risk and wildfire risk, but also having the opportunity to discuss this knowledge in terms of how hazards are, the behavior of the hazard or the risk, also from a very practical view from the civil protection perspective. So we did this simulation and we just try to identify the main decisions to be taken in the case this situation happened. I'm moving fast to be on time. In the second exercise, well, there we met the knowledge in terms of risk behavior, which is quite interesting in terms of avalanche and fires, because normally avalanches are gravitational behavior as a hazard. So the most sensitive areas on the top, who is providing protection, and the main impact is in the bottom of the valley. But normally fire will have the opposite behavior. So normally the main impact of the fire will be on the top of the mountains, where there is the most sensitive area for the avalanche protection. So the challenge is quite big. Basically, this is a summary. We try to make a kind of solution of compromise between how to make how to meet both objectives of avalanche protection and fire prevention. And the last exercise we did, or the last case study, is, as I said, in the valley of Nuria, where there is a railway, also a ski resort area, and it's a very popular area. So there we cross-link in the sense that was Matthias explaining before. We try to cross-link the information between the avalanche hazard, also potential fire situations there, especially those fires able to affect the canopy and the exposed elements. And we are still conducting this assessment in terms of trying to identify not only the impact of new areas at risk, but also the implications of this, because as I saw in so many presentations today, with this enlargement of risk, there is also some implications in terms of who is paying for what and who is going to assume all these new risk situations and prevention measures related, etc. So we are also trying to include in this case study a governance reflection about how to involve not only the public bodies, also the private actors in reducing the risk. So really trying to summarize and be very short in my presentation, here we highlight some key findings thanks to these operational tools. At a landscape level, there is a need of improvement about the data availability, able to cross-analyze this forest protection function that is not always mapped. Sometimes even it's not legally recognized in some cases. New potential high-intensity fire areas according to the climate change, especially those able to affect the canopy, and therefore the forest protection function, and exposed elements of the territory from the combination of both risks, because maybe we have a cartography of exposed elements for avalanche, but not yet for the combination of both risks. In case of this multi-cascade, even they will be rare, they are possible. And this also makes an extra effort in terms of multi-agency cooperation, because there is a lot of work to do for those risks that are in the area. So the steps to do in terms of assuming the cooperation with new risks are becoming also big. And of course, because this, in the case of a multi-risk, the time between restoring the forest protection in case of fire before the snow arrives is very slow. So this means that also we need to include some risk management measures able to compensate this short time for reaction. At forest stand level, should be a better knowledge and more research should be done to really be able to establish these prescriptions at forest managers levels, able to meet both objectives. At individual, social, and expert level, basically to say three ideas. We need, I mean, this is a good example of the need of making local communities aware about the new risks posed by climate change. And I'm including in the local communities, of course, the mayors, that they have a lot of priorities, etc. And this is an important discussion also about if, when we have a lot of priorities, if we are able to assume new priorities that are becoming with climate change. This makes that it's not always easy. And or for instance, just this also help us to understand how important is the landscape management to prevent fires, and how prescribed burns in mountain areas that are there can be understood as a, let's say, nature-based solution for risk mitigation also, and also framing all this from a risk reduction strategy is necessary. Be proactive in this exchange of knowledge. So it's much more easy to move the knowledge from the wildfire expertise and meet with the experts of Avalanche that wait for mountain risk managers, experts on fire. So it's the objective of this project in some way also to exchange these levels of expertise. And finally, be able to reinforce these common multi-agency prevention and overall civil protection plans to be able to focus the prevention in terms of protection the values of the territory, and this also can help local authorities to manage in a best cost-efficient way normally the limited resources they have in mountain areas where they are short, are small communities and not always with enough resources. Well, and that's all from our side. And as I said, remember that all the tools that are presented these days, you can find the detailed reports in the project website. Thank you very much.
Thank you. Now we will carry on. Now with the wildfires. So there will be three presenters: Marta Serra from CTFC, Guilherme Canaleta from Pau Costa, and Catarina Sequeira from our institute. And the name of the presentation is Integrated Wildfire Risk Planning and Community Engagement. So Marta, please come here.
Okay, thank you.
To change the slides, it's in here.
Okay, but
we need to wait a little bit.
Yes.
Look at the end of the lady and you will see when you can. Okay, you can.
Okay, thank you all. So I will try to go fast because we are a bit late. So within one of the support tools developed within RECIP project, there is one related to wildfire risk, and it's developed in 3 different parts or topics. And one of those parts is the development of an integrated risk assessment and planning for landscape and wildland-urban interface. So what's this? This is a methodology to analyze wildfire risk in a specific context and location, taking into account the risk factors, especially the vulnerable and exposed elements, and the whole risk management cycle, that is prevention, preparedness, response, and recovery measures, and the interconnection within them. How is it? The method consists in to apply a specific assessment sequence based on the previously explained to 1, first, identify and map the increase and mitigation risk factors, taking into account the territorial dynamics and the interaction between the natural spaces, let's say, or open spaces, and exposed and vulnerable elements, trying to answer this type of questions you will see on the screen. Second, to establish and identify the actors and the stakeholders related to those activities or actions which increase or decrease the risk. 3, to assess the current risk mitigation measures collected in the different instruments or tools, not only those planned related to wildfire management, also those related to land and urban management, for example, and other ones. And 4, to complete the measures based on the previous vulnerable and exposed elements identification and analysis, and trying to enhance and optimize the synergies between prevention, preparedness, response, and recovery developed through different instruments and actors. So, where we are applying this tool? We have chosen Albrook municipality located in central Catalonia, Spain. This is a territory that has a complex territorial diversity for different reasons, as it's a big municipality territory with around 50 square kilometers, but with only 2,000 people living. So let's say the management capacity is little. Also has different and a lot of elements as 2 natural parks. One of them one of the most important of the Catalonia, and is also very close to Barcelona and has a lot of visitors. There is an infrastructure network with different typologies as highways, railways, and other type of roads, and different land uses as industrial, forest, crops, urban, etc., and different types of settlements as urban sprawl, wild urban interface, and compact settlements, etc. And the most important characteristic that is a high wildfire risk territory affected by different large forest fires, as in 89, 94, and 2017, etc. And yeah, this is the last one. Why we are doing this? Well, the main objective of this tool is to optimize the synergies between prevention, preparedness, response, and recovery, jointly addressing the physical and social vulnerability of the territory. This can offer a reference framework where the activities of the territory are part of the risk management cycle from a cost-efficient and resilient community perspective. All of this to work together to a wildfire resilient communities and landscape adapted to impacts posed by climate change. So that's all from my part.
No, okay, thank you. So after the risk analysis that Marta just explained, we carried out two different activities with the aim to raise risk awareness among the Albrook citizens. Okay, so these two actions have been the educational program at primary schools. This was done in April, so some months ago. And the other one, the Preparedness Day for citizens exposed to risk, so citizens and communities living in the wild and urban interface that will be done next week on Wednesday. We had to do it before summer, but due to the pandemic, we had to postpone it until next week. Okay, so I will start with the first one, Mefito, which is the name of the educational program. Mefito has 4 main objectives. In the end, is to share the appropriate and with the children appropriate and sufficient skills to see forest fires from a critical point of view. We try to make them understand fire as a natural element. We explain them that we wouldn't be here without fire. We have evolved together with fire, but then we have to explain them that how was the transition from fire, so from good fire to wildfire, and the problem that this situation arises. And then we present the forest management as a good tool to reduce the risk of having large wildfires. The program, by the way, is called Mefito because it means Mediterranean Forest, Fire and You. I'm sorry, it doesn't work in English. It works in Catalan and Spanish only. And it's composed by 3 different activities. The first one is an activity in the classroom. Okay, we explain them, we have a presentation and videos, and we explain them that we have evolved together with fire, and fire has become a problem together with the rural exodus, and what I mentioned before, that forest management is a key tool for risk reduction. Okay, then we make with them a forest fire workshop. Basically, we build 2 forest scenarios with paper trees. Okay, in one of them represents a managed forest, and the other one represents an unmanaged forest. Okay, so once we light a fire, real fire, into both the scenarios, they can easily see by themselves how the managed forest doesn't burn, or at least burn at a very low intensity and speed, and how the managed forest burns in just a few completely burns in just a few seconds. And then after doing this, we go to the field and we make a field visit. In that sense, we always try to adapt to the scenario of the school. So we visit fire station in some cases, or a recent burn area, or a wildland urban interface, water points, anything that could help us to build a speech and make them understand the things and the concept that we have explained previously in the class. And the other action that we will make next week with Brook citizens, it's called Upper Partners Day. I don't know if you have heard about that before. It's a transnational activity that takes place every year, the first Saturday of May. As mentioned, it was not possible that day due to COVID. It was initially developed by the Natural Fire Protection Association from the States, and it was transferred later to other countries in the world, like South Africa and other parts. And we are working on that in Europe, for example, in Italy, Spain, and I don't know if in Portugal as well. Then the objective in the end, it's very simple. It's to engage people exposed to the risk, so that they understand this risk and they can create together risk reduction actions. Okay, in that sense, Per Partners Day can be very diverse. For example, in our group, we will make a door-by-door activity and to communicate to the citizens the risk. But we could organize site visits to make a risk analysis together, or co-creation meetings to find solutions. But in my opinion, these are further steps, and the first point is to make them understand the risk with a meeting or a door-by-door activity. So particularly next week, we'll make the activity, the door-by-door activity in Montserrat Park. It's a community very exposed to the risk due to its location. Okay, we will make the activity together with Catalan Receipt partners, but also the fire service, forest defense volunteers, the police, the city council as well. And we will have mixed groups to carry out the activity. So we will mix between us to make groups of 3-4 people, more or less, and we will assign streets to each group, so that we cover all the area and we do not repeat ourselves in the same house. And in each house, the idea is to have to communicate them the risk, to make them understand that they are living in a risk area and that they have to undertake preventive measures, risk reduction measures. And we also will share some information material, like a brochure to keep on their homes. Even it is useful as well for the houses where there is not anyone. We can leave some information. And beyond the Preparedness Day, I think that beyond the Preparedness Day, we could go further and implement a Firewise, which is also a concept developed in the US, which is about developing fire safety communities. Okay, once we make the Preparedness Day and people is engaged on starting this process, we can explore the possibility to become a Firewise and make risk analysis together with the citizens, develop action plans for risk reduction activities, like having meeting all one day all together and undertake preventive actions, and make the communication to other communities, so that this concept can be spread in the region. So thank you, and now Caterina, the floor is yours.
So good morning, my name is Caterina. I'm from the Portuguese team. And over the next 5 minutes, I will briefly introduce you to a tool we have developed to prioritize fuel management at the wildland urban interfaces in Portugal. Okay, so in Portugal, each municipality defines a municipal plan to protect forests from fires for a 10-year period. And this plan is defined according to a guide that follows all requirements established in the law of the national, the regional, and the district planning to protect forests from fires. So it includes determining the fuel management bans according to legislation, which means that around infrastructures, there is a certain area to be treated. As we have in this table, it can go from 10 meters to 100 meters around each infrastructure. So the area resulting from this application of the law is quite vast in wildland urban interfaces because of the high number of infrastructures to be considered in their design. And despite all area is important, not all areas to be treated have the same priority of fuel treatment concerning forest fire prevention. Plus, there is a legal deadline to perform these activities. And it will mean that not only the high number of private owners that have plots within these fuel management bans may likely have to be reminded of this mandatory character, but also that the authorities must inspect all plots treated. So from that, it would be useful if the municipalities developed a database of plots to be inspected annually according to fuel management priorities for fire prevention. So it will likely help to better targeting the authorities' intervention in the field, obviously from a technical point of view. So here is our tool, our decision support system to prioritize fuel management. It intends as being as simple as possible in order to be valid and be adapted to each municipality. And it intends to have a very clear and easy to replicate methodology for identifying these critical areas for fuel management. So the materials used for this system, this roadmap, are available in every municipality in Portugal because it is mandatory to produce this municipal plan to protect forests from fires. So the process is based on this simple binary matrix where value 1 stands for need to prioritize and value 0, no need to prioritize. So this binary classification then is applied to each box of the roadmap I showed you before, and then it is combined following this same roadmap using very simple GIS operations. So here priority will be given to areas that show lower community risk preparedness and areas that present a higher fire risk. We applied this tool to the municipality of Mafra, we tested there, and this municipality is very concerned with fire prevention actions, and in general, it has seen both burned area and number of fires following a decreasing trend over the last decades. And this also, the civil protection from Mafra is very keen on promoting community engagement. So it's an interesting case study. So here is a list of the materials needed, and all of the materials are owned by the municipality. And here's an example of the step-by-step methodology we provide to design these critical areas for fuel management. And here I will not go into detail, but the results of this methodology are a map and a detailed list of plots ranked by priority for fuel management. So as final remarks of this study, I would point out that Mafra has around 31,000 properties in register with different property owners, and around 44% of this total area is located in fuel management bands, which is a lot for one municipality. And in this fuel management band, it is mandatory to perform fuel management, and it is also mandatory to inspect it. So this tool we have tested here classified around 23% of them, of these fuel management plans, as non-priority for fuel management for fire prevention. So we believe it corresponds to an optimization of inspection resources and also community awareness, because these activities of community awareness will be targeted to other higher priority floods. So the goal here is to keep working along the municipality and to provide them with other things they feel are important for municipal prevention, and also obviously keep improving our tool according to municipal needs. Thank you.
Thank you, Catarina. So now we will follow to the next presentation from our team. So to be from Chiara Franciosi from CIMA. And the presentation will be about the participatory and integrated approach for civil protection planning, the flood case study in Cinque Terre. Not bad, not bad. Do you want to continue? No. No? So this is to change the slides. Okay.
How many minutes?
You have 10.
No.
Okay, well, you are Italian. So.
Okay. Thank you, everybody. Because of the time. Because of the time, I try to shorten my presentation, and I go deeper on the case study and some inside of the case study. So my topic, our topic, is to explain the implemented approach that is the participatory and integrated approach of civil protection planning. And our case studies is located in a fragile territory of the Liguria region that is named Five Lands of Cinque Terre. The topic, the hazard topics for us is hydrological risk. So let's go. Sorry, I don't know if. Yes. This is the main topic of my presentation, and I prefer go deeper on the main topic and the main argument of my presentation. So, as previously illustrated, the project framework is about how the civil protection system can be affected by the climate change and therefore possible solution, focusing on the flood hazard. And according to the stakeholders interviews and the literature reviews, we can say that the climate change affects flood hazard and could produce more extreme material hydrological events, and this is could cause a high problem for the civil protection. In this slide, sorry, I put some two events that happened in the Liguria region and in Spain in the last year, only for demonstrated what are the potential impact and the actual impact of the climate change. And so we can say that the civil protection system have some needs, have to cope with some challenges, that is improving the relationship between the preparedness phase and the prevention phases, and co-design the civil protection action with co-designing the civil protection action with local stakeholders, important local stakeholders, and so our issues, our research question is how can we support the civil protection, municipality civil protection actors for coping with the extreme event that the climate change will be produced in the territory. So we think that the best way to support the civil protection actors is to implement a participatory and integrated approach for defining the civil protection planning. So I'd like to spend sometimes a few minutes really for defining what we think, what we define for civil protection approach, so participatory approach, sorry, for this, civil protection planning. So it's well known that the participatory approach is a governance process which favors stakeholders engagement, that favors the match of local and scientific expertise and the co-design of civil protection. So we can say, in other words, that the participatory approach for civil protection planning can produce a greater knowledge and greater awareness of the local risk, a greater sharing of responsibility, and civil protection action more adapted and more shared with the territory. The other approach we used is we implement is the integrated approach. The integrated approach is, we can say that is a based system approach. And with this approach, it's possible to better understanding the different elements that interact with each other, and with this, using this approach, it is possible to realize a better integration, a better exchange of the information deriving from the different local planning, and so it's possible to have a wider vision of the territorial context. This is I go deeper on the case studies, and only some remarks on the Five Lands. Five Lands is located on the Liguria region, is composed by 3 municipalities located on the sea. The main elements, the most important elements of the territory is the presence of the terraces that define and that change the ecosystem, but unfortunately, in the last decades, the rural abandonment, the agricultural and the rural abandonment of the territory have weakened the role of water retention of this hydrological opera, and so the flash flood will increase in the territory, like the events that happened in, I think, 10 years ago. But moreover, the territory, the Five Lands territory is a context, is very complex territory because of there are many or several local authorities that are in charge of civil protection and that are in charge of territorial planning. For example, we have 3 municipalities, the Liguria region, the prefecture, that are in charge of civil protection, and there are national park and the municipality that are in charge of planning. From point of view of hydrological risk, the territory is characterized by small river basin that means that there is very little time to coping with an event, and to implement civil protection action. Moreover, an important part of local economy is composed by tourism sector that is composed by many people that are usually daily tourists that are not Italian, and that they have a few scenes awareness of the hydrological risk present in the territory. No. Yes, sorry. This is a roadmap of the planning, the civil protection planning process that we have implemented in the Five Lands. You can see that is composed by 5 main steps. The first step is the context analysis, and we try to include in this context analysis the climate change impact at the local level. After this, we map the stakeholders to be involved in the process, and they belong to preparedness phase and prevention phase. And with these actors, we define the objective of the civil protection planning process, taking into account the civil protection needs in the context of climate change, and starting from the tourist sector, The fourth step is the formalization of this interinstitutional working group, and finally we implement the process. Our idea is that using all these steps, the civil protection plan can be improved and will be more suited to local context and to disaster risk management and climate change adaptation framework. I'd like to focus or stress my presentation or my speech on two phase steps. The first step I'd like to underline is the formal institution of working group. We think that is a very important phase of the planning process, because in this phase it is possible to define a wider vision of the context, because the different local bodies involved in the group are in charge both in civil protection, both in territorial planning. So they can discuss each other, they can confront each other, and they interact each other. So it's possible to define a more clear definition of the role and the responsibility in regarding of the different risk mitigation action put in the territory, and it's possible to bring out any synergy for better defining a risk mitigation in the territory. So this is for us is a very important topic. The other topic is that we start from the needs, as I said before, from the needs of the tourist sector. And we think that starting from this sector, it is possible to mainstream the civil protection needs, the risk mitigation policy, and the climate change adaptation into sustainable development, because the tourism sector, as I said before, is a very important part of the local economy, but at the same time it represents a high vulnerability in relation of hydrological risk. So we think that matching the economic development and the risk mitigation is possible to produce a sustainable development. So our question is, can addressing tourism sector risk management be an opportunity for improving territorial resilience? And for answering this question, we discuss with the working group. The working group define some possible solution for define the action for saving the tourism sector and avoiding to penalize the economic sector that is the tourism sector. As can you see, the different actions proposed during the discussion of working group are related to the capacity to reduce the improve the capacity, reduce the exposure and the vulnerability. In particular, all the stakeholders involved in the working group are engaged in the definition and implementation of each, as you can see in the slide, in each action. And in particular, we like to speak a little time on two actions proposed, the improving of local early warning system and the reducing of number of the train before and during an event. These two actions can act on the capacity and the vulnerability and on exposure, and they are strictly integrated, because improving local early warning system means that we have to define, or better, municipality have to define a rainfall threshold for put an early warning for reducing a signal for reducing a number of trains for limiting the presence of the tourists in the territory. So this is for us is a good example of sharing the responsibility, because we have the municipality, but also the Liguria region and the prefecture, and integrated the measures, because here we have for improving the early warning system, produce a improvement of the capacity, and so we are in the preparedness phases. And for the action related to reduce the number of train, affect the exposure and in part of the vulnerability, and so we are in the prevention phase. I go to the conclusion. Okay. The first conclusion, the more simply conclusion, is that the participated and integrated approach responded to the requirements of mapped requirements of civil protection and the mapped requirements of risk managers, because using this approach is possible to strengthen the collaboration between institutions at a different level and reinforce risk awareness and risk perception. But the other conclusion, an early conclusion, is that using these two approaches is possible to shift the civil protection plan from preparedness to prevention phase. And so a civil protection plan could enrich and could have a wider and overall view and the impact on risk reduction. And so we think that using these two approaches is possible at least reduce the new vulnerability and exposure, at the best improving an actual and the future risk mitigation measures.
So thank you so much, Chiara. So we are running really late, so we don't have the time to have questions and answers. But if you have some questions, please just send us an email, because our researchers will have all the pleasure to reply to you. So no problem with that. And so we follow to the closing session. That will be with Evangelia Zartzu and Joy, this is problem, Kasseneleng-Bogen, I'm so sorry, I cannot say your name. That it's from the DG ECHO, from the European Commission. And just before we end with this closing session, just to remind you that tomorrow at 9 a.m. Portuguese time, 10 a.m. Central Europe time, we will start again with two roundtables that will be really interesting, one on risk communication and the other with the financial instruments to deal with the natural hazards. So Evangelia, I think you are there.
I am here.
Okay,
I'm here. Good afternoon, everyone. Just a moment to try to upload a very brief presentation. Thank you. Okay.
Okay, 20 minutes maximum, please.
Of course.
Thank you.
Just a moment. Okay. Can you see some? Okay. First of all, can you hear me or not? Sorry, can you hear me? Can you hear me? No?
Yes, we can.
Can you hear me? Okay.
Yeah,
just
very
a
well.
No problem. Because okay, just a moment. Share again. First of all, thank you so much for inviting me and my colleague Joy as DG ECHO that finance this very interesting project and also really today its case study, its presentation was really very useful, very insightful, And I would prefer each presentation and each case study to be like a good example for other countries to be followed, like how this multi-risk assessment is a very useful and very preventive tool to reduce disasters. Also, you enlightened us, and for example, I kept some two new elements for me. In Italy, the last presentation, that in a risk analysis, apart from risk, exposure and vulnerability, added the word capacity. And another presentation, very interesting element, how the recovery, there is synergies between recovery and climate adaptation and disaster risk reduction, and could be also be taken into account the disaster risk management process. And of course, this participatory approach and how to communicate risk to population, and also how to cooperate multi-agencies for different risks with civil protections. Very interesting. Very briefly, some key concluding points from our side to be taken into consideration. Okay, it's like as Margarita today very well presented the wildfires in Greece, and this summer also we witnessed a lot of forest fires in also in Mediterranean region. This Mediterranean region this year experienced the worst heat waves in decades. And we witnessed the largest UCPM deployment in the last 10 years. And also the pictures that from floods took place in Germany, in Belgium with human losses, and also in also Netherlands and Luxembourg. All of these pictures offer a glimpse into what future might be like. Also, of course, the climate change plays an important role in exacerbating these very extreme weather events. The very recently published IPCC report confirm that the changes in climate are the underlying causes of prolonged droughts and also these very record-breaking heat waves, triggering forest fires and also increase the risk of floods. And at EU level, the economic losses from these extreme weather events is about 12 billion every year, 12 billion euro. In this regard, multi-hazard risk concept, the risk assessment concept, has got a lot of attention in the last years, as this constitutes the basis of really an effective disaster risk reduction strategy. In this regard, Commission, under the Article 6 of UCPM legislation, supports member states to carry out national disaster risk assessment and management plans. To that end, these results of this project are very promising, and we are expected to feed and contribute to our guidelines to facilitate member states to have this multi-hazard risk approach that we started in 2010 with a staff working document, risk assessment and mapping, introducing multi-hazard risk assessment scenarios the risk to evaluate the risk level. And also in 2019, with the amendment of this article of this UCPM legislation, we issue another reporting guidelines, strengthen this multi-hazard risk assessment approach. Of course, there are a lot of gaps and weaknesses to perform national risk assessment and management plans in terms of methodology, in terms of data availability, in terms of how to develop a multi-hazard risk criteria in this matrix risk, and how to calculate, of course, the consequences in quantitative terms. And also, this project is very important for us since that the multi-hazard risk assessment approach, it's relatively new. There are only a few multi-risk models. Also, the experience of practitioner and national civil protection authorities how to use these models is limited. And also, again, this multi-hazard risk assessment is a preventive tool how to evaluate the risk, how to map, to help policymakers to develop evidence-based national disaster risk reduction frameworks. As also the output of this project is a useful decision support tool to understand and to distribute of losses in a different sector and compare risk scenarios with each other, to prepare and plan for a multi-type disaster in a region and optimize the allocation of resources like financial resources, human resources, infrastructure, early warning system, to communicate multi-type risk parameters to different stakeholders and of course the public in general, and to develop a comprehensive disaster risk reduction strategies. And very important that these tools can influence the perception of different stakeholders. And I would like to stress out that an effective disaster risk reduction strategy demands not only a comprehensive risk assessment scheme, but also it's very important, as many of you mentioned today, this an appropriate communication mechanism to risk, communication risk, and its underlying drivers to all stakeholders involved, all involved stakeholders in the policy making process. And another new concept is like risk governance that needs to focus on the role of the various stakeholders' participation and communication into this multi-risk assessment process. More attention to new and emerging risks because of climate change, like today, it's how this also new risk like avalanches. Today, how these avalanches affected the tourism and landslides, many other things that in the past were not so common. More research is needed to develop models, methodologies, and gather data to allow for a quantitative risk estimation. That is a big challenge, this quantitative risk estimation, and also to take actions to facilitate and share the knowledge and the results of research projects. Like today, we need to strengthen this dissemination strategy of recipe project. I have chosen this slide in order to give you a picture how complex and how difficult task is to have this multi-risk analysis. How in this risk matrix, how many different scenarios can fit in this matrix. And of course, very briefly, that this disaster risk reductions, this concept, including the multi-risk assessment approach, have been integrated in new policies for this programming period under the Green Deal initiative, like climate change adaptation strategy, new EU forestry strategy, The concept of nature-based solution to reduce natural and climate-related risk has been integrated in the most of Green Deal policies and initiative. The new EU forestry strategy, for the first time, the Commission puts forward a new legislative proposal on EU forestry observation, reporting, data collection to ensure a European coordinated forest monitoring, data collection and a reporting system. Of course, under the EU biodiversity strategy, with these two commitments to enlarge Natura 2000 network of protected areas, and also to define specific restoration targets per each ecosystem, with its ultimate goal to reduce, to prevent and reduce natural and climate-related risk. And another strategy is like a farm to fork strategy, that this strategy also is the development of a contingency plan for food security and food supply, that also includes a common EU food crisis response mechanism, that this mechanism will include also food security risk assessment and monitoring tools. And we have also for the next programming period many European financial instruments. Most of the countries have already submitted to the Commission their national resilience and recovery plans with disaster risk prevention and reduction investments. And the Cohesion Policy Fund for this programming period, under the policy objective 2 and under also the specific objective 2.4, how to promote climate change adaptation and disaster risk reduction and resilience, taking into consideration ecosystem-based solutions, will promote and support member states to implement disaster risk reduction, prevention and reductions investments. And the CAP strategic plan 2023-2027 that are under development, and some drafts that we received also include some other prevention and reduction practices in the agricultural and forest land. And of course, the Erosion Europe research project will continue to support member states to our interest area, like multi-risk assessment approach. It's not coincidence that also the previous time supported a call of how to have an integrated landscape fire management approach. And the LIFE, of course, will continue to support the project under the pillar of climate change adaptation. And I would like my last slide is how DG ECO will continue to support member states with guidelines. It's very important to have the feedback and the results of this project to contribute to this guidelines under the Article 6 of UCPM legislation. Also, we work on a pan-European forest fire risk assessment that will be finalized by the end of this year in order to have a common methodology on fire risk assessment process. We'll continue to provide risk monitoring tools, an early warning system, EFIS, IFAS. We have also this Copernicus emergency services. We continue to support with direct grants to national civil protection authorities by increasing their technical capacity to implement disaster risk reduction strategies. And we continue, of course, to support the multi-country project on risk prevention and preparedness. We will have some new calls in 2022. And also we provide peer review advisory missions on disaster risk management after request of member states. And also for your interest, we have an interesting project, European Risk Data Hub, that it's like a web GIS web platform providing European risk data and methodology for disaster risk assessment. All of these key concluding points from my side, and I will give the floor to Joy in order to present something that also we discussed today, how finally the prevention could be, apart from cost-effective solution, how also to provide some multiple other benefits like environmental benefits and social benefits as well. Joy, the floor is yours. Thank you from my side. Just a moment to close.
Hello, good afternoon to the very resilient ones of you who stayed. This is going to be very short, I reassure you.
Okay.
Can you see the screen and hear me? I think so, right?
Yes, we saw.
Great, so I will put it in presentation mode. Voilà, so I just have a couple of slides to present to you this very interesting study that was published very recently. That's called Economics of Disaster Prevention and Preparedness. So that's a study that we in the Commission have ordered to the World Bank. It's a cooperation. And it's an attempt at putting figures, in fact, on something we didn't have so far. So this is a study that includes 3 components, as you can see on the screen. And the idea is to raise attention to it. So everything is available on internet, and we have conducted 3 workshops the last 3 Fridays on every component. So the first component is about modeling of the disaster risk in Europe. The second one is about financial risk and opportunities to build resilience. And I believe that tomorrow we're going to discuss that further. So that's also linked to tomorrow's discussion. And the third component is investing in disaster risk management in Europe makes economic sense. So that's the one I'm going to just briefly introduce to you today. And so all these 3 workshops are recorded and you can access them. I will give the links at the end. And we're also working on an e-learning, so a training course that would be available to everybody in the near future. So just to give you 2 figures that are very striking, I think if you analyze them, that every year between 1980 and 2020, disasters have caused that are caused by natural hazards have affected nearly 50 million people. That's enormous. And this resulted in economic loss of 12 billion per year on average. So this is an enormous amount, and they're actually expected to increase if you take into consideration climate change that manifests itself more and more. And for us also, the investments in prevention that aim to reduce disaster and climate risk can actually help also to reach the climate neutrality that we're looking at for 2050 under the Green Deal. So this, simply put, is a study by the World Bank. It's carried out a cost-benefit analysis of over 70 investments in prevention and preparedness. That's where they took the data from. They focused in this study on only 2 hazards, earthquakes and floods. The idea is perhaps to extend that in the future to other hazards. And it shows actually that investing in disaster risk management makes economic sense. What they have also used is an approach that is called triple dividends of the resilience. And that's actually a very interesting concept. It's a concept, I mean, investment in disaster risk management have a first obvious impact that everybody knows is to avoid losses by saving lives, by reducing people that are affected, also by reducing damages to infrastructure and other assets, and reducing losses to economic flows. So this is the kind of obvious impact that most people would naturally know. But what they found out is that there are other advantages of investment. and positive impact. So another positive impact is the unlocking of economic potential. So sometimes investment can actually stimulate economy, and it's due to the reduced disaster risk, but it can also be due to more productivity, or also to fiscal stability and access to credits. So these are kind of spin-off effects of the investment. And there's a third dividend that it can generate co-benefits, not only of economic nature, but also they could be social or environmental co-benefits. And that actually is regardless of if the disaster occurs or not. So it's quite interesting as a conclusion. So that's very well explained in the report that you can download, and you can also watch the workshops. So here I've put a few links for you. We will send the presentations so that you can just click on it. But these are the links to the World Bank study with the report and a short video, promotional video that is very nice, and explains in 3 minutes what it's about. You can find the recordings of the 3 workshops about the three components of the study. And I've put also the link to the Union Civil Protection Knowledge Network. That's one of our newest initiatives where we want to support the development of civil protection capacities at national level. And there will be a launch event in December. And then also a link to the Joint Research Center. They've published a very interesting report as well that is based on, well, effects of climate change as well. So voilà, I want to thank you for all of those who are still there, and we'll see you obviously tomorrow for the rest of the workshop.
Thank you so much. It was so interesting. Of course, Eva gave us all the information about the proposals and the different things that we can have funds from the European Union. And for me, it was really interesting, this last part, because I had no idea about this report. So it was very good. And it's a great link to the workshop of tomorrow, where we will have a discussion, a roundtable exactly about this part of the economical issues related with natural hazards, and of course risk communication. One of the things that we were all talking during this morning was about how to engage people, how to engage the population, to make them more aware and also more involved. So risk communication is one of the tools. So really looking forward for tomorrow. So thank you so much for being here, for keeping yourself next to your computer, and also to my colleagues here at the University of Lisbon. And see you tomorrow at 9 a.m. Portuguese time, 10 a.m. Central Europe time. So thank you so much. See you soon. See you tomorrow.
Thank you,
Bye.
Sue. See you tomorrow. Bye.
Thank you.
Bye. Bye.
See you tomorrow.